Math 1314, Tyler Junior College, Section 1.7, Linear and Absolute Value Inequalities, Solving Linear Inequalities Part 2. In the previous video, we started solving linear inequalities, and for the most part, they were straightforward. We solved them, we drew the number line, we wrote the interval. But at the end of that video, I mentioned that there are some issues we haven't talked about yet. Here's one of them. Solve. Represent the solution as a number line and interval. Negative 3x plus 4 is less than or equal to negative 11. Now, I get the feeling several of you already know what the issue is that I'm going to bring up. Let's see if you're correct. Well, if I wanted to solve this, I would just start doing the things I would normally do. Starting with getting rid of the plus 4 by subtracting 4 from both sides of the inequality. Those cancel, leaving a negative 3x on the left, less than or equal to negative 11 minus 4 is negative 15. So what's our next move? Well, our next and final move for solving is to get rid of the negative 3 that's multiplied. So we have to divide both sides by negative 3. The negative 3's cancel, leaving the x. And the negative 15 divided by negative 3 is 5. But if I write less than or equal to, I've just missed the question. Why? Well, again, some of you already know the rule that I'm going to cite in just a moment, but I don't just want to say, here's the rule, do it because I'm the professor and I said so. I want to give you a reason for it. To show you that reason, I'm going to go back to this inequality before we divide it by the negative 3. And I'm not going to divide by negative 3. What do you mean? I'm going to move some pieces around. For example, I'm going to add 15 to both sides. Why would you do that? You'll see. If I add 15 to both sides, I get negative 3x plus 15 is less than or equal to 0. Oh, you're making it equal to 0. Well, temporarily, because now I'm going to add 3x to both sides. So basically what I'm doing is I'm moving terms around. We've played this game on some equations already. Move something from the left to the right and it changes signs. That's essentially what just happened here. But why did I do that? Why did I do these legitimate moves? Well, what do I divide by now? 3. Okay, nobody's going to question that, and we get x's, well, hold on. This is a backwards inequality. This says 5 is less than or equal to x, but if you were to reread it with the x as the subject of your sentence, 5 is less than or equal to x means that x is greater than or equal to 5, which is the complete opposite of what we got over there. So which one's correct? They can't both be correct. Well, did I do anything here that would have caused it to be wrong? The answer is no. Did I do anything here that caused it to be wrong? The answer is actually yes. But if you really wanted to settle the debate between which of these is the correct solution, pick a number that each one suggests as a solution and see if it works in the original inequality. For example, if you think this is a solution, that means that every number less than or equal to 5 should make this true. Give me a number less than 5. How about 0? Now there's a lot of numbers we could check. You can't check the solution to an inequality by checking individual values, but you can show the solution to an inequality is wrong with just one bad apple. But if we were to check x equals 0, which this claims as a solution back in the original inequality, we would get negative 3 times 0 plus 4 is less than or equal to negative 11. Actually, we're asking the question, is it less than or equal to negative 11? Well, negative 3 times 0 is 0, and then plus 4 is 4. So, is 4 less than or equal to negative 11? Or visually on a number line, is 4 to the left of negative 11? It is not. That means that 0 is not a solution, which means this is incorrect. We could play the same game over here and it would work. For example, if we pick 6, negative 3 times 6 is negative 18. Negative 18 plus 4 is negative 14. Negative 14 is less than negative 11. It's to the left of negative 11. So this is the correct solution, x is greater than or equal to 5. But I don't expect you to jump through all those hoops just to say this isn't the right answer, that one was. I was just justifying that this inequality symbol was incorrect. It should have been the other way around. But I get the feeling a lot of you already knew that. Because a lot of you know the move that says now is the time to reverse the inequality. And that move was the last one we did, dividing by -3. So here's what you need to know about solving inequalities. If you multiply or divide both sides, emphasis on both sides of an inequality by a negative number, I'm going to put a comma there, pause to catch my breath and make sure this says what I want it to say. If you multiply or divide both sides of an inequality by a negative number, comma, then reverse the inequality symbol. So if it said greater than, make it less than. If it said less than or equal to, make it say greater than or equal to. To illustrate this reversal of the symbol, usually what I'll do is draw a little loopy arrow like that to indicate that I am turning the sign around. The rest is easy. The number line, sure. Starts at 5, greater than is to the right, equal means bracket, and so the interval is bracket 5, comma, infinity parentheses. That part's easy. All right, so watch out for reversing signs. Happens whenever you multiply or divide both sides of the inequality by a negative number.